Yeah, so this is pretty rough. It looks intimidating. It is intimidating. I mean, this is really tricky. You got to know your exponent rules to even have a chance at a question like this. If you don't, then know yourself and move on. Pick a choice and just go. Don't waste time on like trying to figure this out. This is either you know it or you don't. So hopefully we can use this as a learning opportunity to memorize the formulas that kind of work into exponent rules. It's tricky. Even with them, it's tricky. So the best thing you can do when you've got exponent rule questions is you kind of want to just take them one at a time. Honestly, one thing that might come into mind here is maybe you can arithmetize, because we have x's and y's that don't seem to matter. So maybe we can just pick a number for them and carry it through the problem. The problem with that is that exponents don't do nice things. So we can't pick numbers as easily as we can for normal regular algebra, because do you really want to be taking like the 1/3 power of whatever number you pick for x? You need to know how to do that even to pick a number for x that makes sense. So it really won't work unless you're in the calculator section and you're very handy with using the decimals and stuff like that. So we're forced here to do it the real way. So the first thing that I like to do is get rid of negative exponents. I think that they just kind of complicate things, and so it's really easy to get rid of them, but for whatever reason, no one can remember this rule right. So let's kind of review it. Basically, what they do is they move a term, let's just say within a fraction. And this is actually a good question for this because it will let me display both ways that it works. So let's use this dark blue so that it's clear what we're doing. So moves a term within a fraction. So y to the 1/2, positive exponent, I don't want to touch it. Let's just leave it as is. X to the 1/3, same thing. I don't want to touch it. Let's leave it as is. But these other ones, x to the -2, y to the -1, I don't want to have negative exponents. They're annoying. So how do I get rid of them? Well, all you got to do is move it within the fraction. So if the x to the -2 is on the top, you move it to the bottom, and it just becomes a positive. Just like that. The negative just disappears once you move it within the fraction. And so if it's on the top, and you want to get rid of the negative, you just drop it down to the bottom. But if it's on the bottom, and you want to get rid of the negative, you move it up to the top. It works both ways. So y to the -1 would just pop up on the top as a regular old y. That's it. So people freak out with this rule. They don't know what to do with that negative. They don't, I guess, like that it disappears. I don't really know. But what ends up happening a lot of times is they bring the negative outside of the exponent and kind of like put it in front of the term. Like they'll say something like, this is wrong, let's just be very clear. X to the -2 is the same as negative x squared. No, 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 no. Don't do that. The negative is in the exponent. It's never going to just pop out of it into the real world. It doesn't work that way. So if it's in the exponent, it can disappear, but it doesn't pop out. So hopefully you remember that. People get that wrong all the time. So okay, this is still messy, but we're starting to see things kind of come together, right? Like maybe we don't know exactly what the answer is, but you might be able to take a smart guess here and be like, well, okay, I see there's a y and an x squared. This one has a y and an x squared, so that seems pretty good. This one has a y and an x squared, but they're in things, so I don't know. If you were guessing, maybe at this point, if all you knew is that rule, you still might guess D, which is the answer, but we can prove it. Let's use the other rule here, which is fractional exponents. So how does a fractional exponent work? Well, you've got, let's just stick to non-numbers here. Let's do a over b. So x to the a over b. That's going to become the b root of x to the a. So the bottom of the fraction is the root of a radical that we invent, we make up, and we put there. And the a, the top, is just, it stays put. It stays as a regular old exponent. So that's the general rule. We're going to see the most common application of this with the y, but just to give you a way to remember this rule, because people kind of forget which is at the top or is at the bottom that goes in the radical. Just remember that the roots of a tree are on the bottom of a tree. So the roots are on the bottom of the exponent, right? The root, the b, is the bottom of the fraction. It's something. I'm trying here. Hopefully it helps. So why does it help here? Well, let's go over to here. So that y and that x squared are going to stay put. But y to the 1/2 is going to become the square root of y. And I'm going to just, in orange, show you how this rule is applying, right? Because look, the bottom of the fraction was a 2. So that becomes the root. And the top was 1, so that stays on the y. But in both those cases, the convention is that we just don't write those numbers, right? We don't write x to the first, y to the first. We just write x, we just write y. We ignore the 1. So that's why, even though choice D is right, it doesn't quite look like that, because the 2 gets hidden because we don't write the 2 when we have the regular old square root, and the 1 gets hidden because we don't write 1 as an exponent. But when we do the x, it is gonna appear a little bit. So the same rule applies, right? Now the bottom, the 3, is the root, and in orange I'll put the 1, which is the top of that fraction. So again, the rule is applying. The only difference now is the 3 gets written because that's how we write it. We write when it's a root that's higher than 2. So yeah, there's my answer. Oop, don't erase it. There's my answer. So it's just 2 rules, but they're complicated rules, and we have to do them twice each, and there's just a lot going on, and then the answer choices don't help because they look super complicated. But there's nothing else to do here. This is the end of the line. And so if we remember those rules, even if it's just like one or the other, you might be able to kind of work your way towards the answer and make a smart guess, even if you're not 100% sure. But this is one of those cases on the SAT where we don't really have a good strategy to help us. We just kind of need to memorize a fact and apply the fact and hope, that we remember it right to get it to work out. So it doesn't happen often, but when it does, yeah, there's points here you can't really get otherwise. So hopefully this worked, but bookmark the video or return to it if you need to remember it. Because yeah, negatives, fractional exponents, hard, but doable.